Hello and welcome. So far, we have looked at polynomial inequalities of first, second, and third degree. And I thought that it would be a good idea if we look at one more example. In this case, a third degree polynomial inequality, which is slightly different than the ones that we have discussed together. I'm going to get started with step 1, which is take all the terms to one side, leave 0 on the other. So what we have in here is x to the power of 3 minus 2x squared plus 5x plus 20. And then we're going to bring all the terms that are on the right to the left. So 2x squared will come to the left side, change sign, negative 2x squared. 14x, negative 14x, and negative 16 will change to become positive 16. We still have the inequality symbol and 0 is left on the right side. Now once we do this, we want to combine the like terms. So we see that x cubed doesn't have any like terms, so we leave it as is. Then we have negative 2x squared and another x squared term, negative 2x squared. I'm going to bring them together. And I'm going to take the steps slowly. What's a rush? Plus 5x, which is the next term. Okay. Plus 5x and my minus 14x. And last but not least, we have the constants. So we have a 20 and we have a 16 in here. So we'll write plus 20 and then plus 16, bigger than or equal to 0. We need to completely simplify this. So x cubed minus 4x squared minus 9x plus 36, bigger than or equal to 0. Now, next thing we want to do is factor. So this was just first step only. Okay, so that was our step 1. Now in the next step we want to factor completely. There are various ways to factor in polynomial expressions, and in this case I can kind of see that it is probably possible to factor by grouping. So notice that here we have x cubed minus 4x squared. They have a common factor of x squared. And negative 9x plus 36, they have a common factor of 9. And what I see here is if I factor 9 in the second group, then I have x minus 4 and x minus 4 in here. So I will go ahead and factor by grouping. So x squared, x minus 4, and then minus 9, x minus 4. Notice how here we ended up with 2 common factors. So x minus 4, they're in binomial form. And then we have x minus 4 in here as well, which means that we can take that out. And the other factor will become x squared minus 9. Okay. Bigger than or equal to 0, don't forget. Now, if you look at this polynomial inequality more carefully, you see that we haven't been able to factor completely yet because we need to factor x squared minus 9 even more. So x minus 4 and then x minus 3, x plus 3, that's the difference of squares. The next thing we want to do is look into the zeros of each factor, which means we're done with second step, which is factor completely. So to find the zeros, we make each factor 0. So the zeros are at 4, 3, and negative 3. And again with this, we're done step 3. Now in the next step, what we're going to do is build the table. So here goes the number line. And here goes where all the factors will be listed. The number line goes from negative to positive infinity. Negative to positive. And here we're going to place all 3 zeros equidistant from each other. Not to scale, obviously, so negative 3, positive 3, positive 4. That will divide the numbered line into the following intervals. So from here to here, we have negative infinity to negative 3, negative 3, 3, 3, 4, and 4 to infinity. And in every interval, I am going to select a testing value since we're here, which we are going to use to test each factor, so the sign of each factor. So a testing value of negative 10, a testing value of 0. Always choose the fun numbers, the easier ones to plug into the equation or expression. X equals 3.5. We don't have a lot of choices here. And x equals positive 10. So the testing values are random numbers that are chosen in each respective interval. Now, down in the first column, we are going to list the factors, which are x minus 4, x minus 3, and then x plus 3. And once we're done, we're going to draw the line and write the product x minus 4, x minus 3, and then x plus 3. So we're going to study the signs of the factors, of each factor, and based on the sign of each factor, we are going to determine the sign of the product. So we start with the zeros of each factor, and we'll say that x minus 4 will be 0 at x equals 4. And at x equals 4, not only when this is 0, the whole product will become 0. Next, we have x minus 3, which will be 0 at x equals 3. And I try to align the zeros in here, okay? Now, when x plus minus 3 is 0, the whole product will be 0. Talking about this product. The last factor is x plus 3, which will be 0 at negative 3. So we'll say that will be 0 at negative 3, and that will make 0 the whole product in here. Now let's study the sign of each factor. So x minus 4 will be 0 at 4. If x equals negative 10 minus 4 is a negative number, negative 14. So we'll write negative here. If x equals 0, 0 minus 4 is still negative, so negative. If x equals 3.5, 3.5 minus 4, negative 0.5, still negative. And if x equals 10, 10 minus 4 is positive. The next factor is x minus 3. X minus 3 is 0 at 3. So for x between negative infinity to negative 3, we plug in the testing value of negative 10. Negative 10 minus 3, negative. For x values between negative 3 and 3, we take the testing value of 0. 0 minus 3, negative. For x values between 3 and 4, we take a testing value of 3.5. 3.5 minus 3, positive 0.5. And between 4 and infinity, we choose a testing value of 10. 10 minus 3, 7. So that's positive. The last factor, x plus 3, will be 0 at negative 3. Between negative infinity to negative 3, a testing value of negative 10 will give negative 10 plus 3, negative 7, negative. X equals 0, 0 plus 3, positive 3, so positive. X equals 3.5 for x values between 3 and 4, right? So 3.5 plus 3, positive. Remember that these are linear expressions, and once they become positive, they will stay positive. And from 4 to infinity, it's positive. Now, a quicker way to assigning the signs to each factor is by looking at their zeros. So if the 0 is, say, for example, at 4, and this is a linear expression with a positive slope, that it means that to the left of 0 it will be negative, to the right positive. That's because a line with a positive slope is positive for x values beyond the 0 to the right of 0, and negative for the x values to the left of 0. This is where 0 is. Right? Okay. So, moving on to the next step. Now, in the next step, we need to find the sign of the product. So for this, we multiply all the signs. So we have a negative, and a negative. So that gives a negative. Next, we have a negative, and then a positive. That will give a positive. Next, we have a negative, a positive, and then a positive. That gives a negative again. And last, a positive, a positive, and then a positive. So 3 positives will make a positive. So now we're thinking, what did we want the product to be? We wanted the product to be bigger than or equal to 0. So a positive or a 0. So this is where the positives are. So we're going to say that x will be between, or will have to be between negative 3 and 3 for the product to be positive. And we also want the product to be 0 as well, because it's bigger than or equal to 0, which means we'll include the ends, joined by x can be from 4 to infinity. And we do want the 0 as well, so we'll square bracket the 4. And there we go. This will be the solution to this inequality. Stay tuned for one more example, as I would like to take an example slightly different than this one again. And I would like to introduce us to polynomial inequalities where one of the leading coefficients is negative. I hope this made sense and it helped you reinforce your understanding of how to solve polynomial inequalities, and I'll see you next time. Bye for now.